Welcome to the Legal Brief, your ultimate Cambridge mathematics strategy session. I'm thrilled to guide you through this explainer where we'll unpack the ultimate mathematical toolbox for solving quadratic equations. Look, whether you are sitting the 0580, 0606, 4024, 4037, or 4040 syllabus, approaching a complex quadratic problem can sometimes feel like walking into a chaotic mess of numbers and variables. But top students don't panic. They approach the exam paper like a top barrister building an airtight legal case. It's all about gathering the evidence, structuring the argument, and delivering an undeniable conclusion. Today, we're going to look at two typical students: Alex, who overloads his paper with raw mathematics facts but offers zero logical analysis, and Sam, who constantly rushes and completely misses the subtle command word requirements. We're going to fix those bad habits right now. We are going to transform what looks like a complicated puzzle into a predictable, step-by-step process that guarantees you maximum marks.
Okay, let's dive into our logical progression for today's session. First, we'll meet the quadratic and understand its core structure. Then, we'll present Method 1, factorizing. Next, we'll shift to Method 2, completing the square. Fourth, we'll bring in the heavy artillery, the quadratic formula. And finally, we'll tie it all together by applying these strategies to real-world geometry problems.
Section 1. Meet the quadratic. First up, we need to clearly define exactly what we are dealing with. You can't cross-examine a witness if you don't know who they are, right?
Now notice how the a, b, and c are our known values, our integers. But that little squared symbol, that is the absolute defining characteristic of the entire equation. If the highest power of your variable is a 3, you're dealing with a cubic. If there is no visible power, it's an invisible 1, making it a linear equation. It absolutely must be an x squared to open up this entirely new world of problem solving. This is where we apply the PEL framework: point, evidence, explanation, link, to our math answers. Your point is identifying it's a quadratic. Your evidence is that squared term. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Let's move to Section 2, our first and often most efficient tool, solving by factorizing. This is your first line of defense.
Now, what's really interesting about this slide is this simple but profound anchor rule that makes the entire factorizing method work. If two things multiply to make 0, then one of them absolutely must be 0. It is mathematically impossible to multiply two non-zero numbers and get 0. This is the legal precedent upon which our entire solving argument rests. If you understand why this works, you've already won half the battle.
Let's walk through this logical transformation. We start with x squared minus 3x minus 10 equals 0. Now here's where Sam usually messes up. Sam tries to do the whole thing in his head, rushing to the final answer. But the examiner needs to see the explanation. We need to find two numbers that multiply to make negative 10 and add to make negative 3. Those numbers are negative 5 and positive 2. So we rewrite the equation explicitly as x minus 5 times x plus 2 equals 0. This is your evidence. Then, applying our zero rule, we explicitly state that either x minus 5 equals 0 or x plus 2 equals 0. Solving these two simple linear equations gives us x equals 5 or x equals negative 2. It is absolutely vital to show this full, step-by-step transformation. Don't be like Sam and skip the middle steps. And don't be like Alex and write a paragraph of text. Keep it clean, keep it logical, and secure every single method mark.
Section 3. Method 2. Completing the square. Sometimes factorizing just isn't possible, which brings us to our second structural tool.
When you can't easily find two integers that multiply and add perfectly, you don't panic. You simply pivot to this method. Completing the square is incredibly powerful because it reshapes the equation into a format that reveals its core properties without changing its actual mathematical value. It literally forces the quadratic into a corner where it has to reveal its solutions. As an added bonus, arranging an equation this way immediately hands you the coordinates of the turning point on a silver platter, which is absolutely essential for those tricky graphing problems in the 0580 syllabus.
All right, let's treat this like an interactive workshop. Imagine a 60-second timer on your screen right now. I want you to spot exactly where students lose marks here. We start with x squared minus 4x minus 2 equals 0. We take half of that middle negative 4 to create our perfect square bracket, x minus 2 all squared. Now here's the flaw trap. If we expand that bracket, we get a positive 4 at the end, but our original equation had a negative 2. To get from a positive 4 down to a negative 2, we must subtract 6.
That adjustment is the critical pivot point, and it's where Sam always drops a negative sign. So the logically identical equation is x minus 2 squared minus 6 equals 0. We move the 6 over, take the square root, and remember it must be positive or negative, that's another huge trap, and we find x equals 2 plus or minus the square root of 6. Time's up. If you caught that positive-negative square root rule, you are already thinking like a top-tier candidate.
Moving on to Section 4, now we reach the climax of our mathematical toolbox, the quadratic formula. Stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
There is a beautiful, undeniable logic to how this formula is created. It isn't magic. When you take the general form equation, ax squared plus bx plus c equals 0, and you algebraically apply the exact completing the square method we just went over, a miracle happens. You divide by a, complete the square, rearrange it with a common denominator, and take the square root. Doing this step by step brilliantly creates the famous quadratic formula. It's not just a random collection of letters, it's a direct, rock-solid mathematical derivation. This is the ultimate proof of our mathematical case.
And here it is, the heavyweight champion of algebra. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This formula guarantees a solution for literally any quadratic equation, provided you carefully organize your data first. And I want to draw your attention to the part under the square root, b squared minus 4ac. This is known as the discriminant. It is the core piece of evidence that immediately tells you whether your equation has 2 solutions, 1 solution, or none at all. It's like checking the DNA of the math problem before you even start calculating.
Okay, time for another quick interactive challenge, the data scan. You have a complex equation, x squared minus 4x minus 2 equals 0. Before substituting a single thing into the formula, you need to explicitly extract your a, b, and c values into a table just like this. Why? Because this completely prevents those critical negative sign errors that plague students like Sam. Here, a is positive 1, b is negative 4, and c is negative 2. If you just rush and drop a negative sign when moving to the formula, your entire equation collapses and the examiner will show no mercy. Visual organization like this table is your absolute best defense against silly arithmetic errors. Treat it as your undeniable fact sheet.
Now let's decode the command words because this is where the Cambridge examiners lay their cleverest traps. Pay very close attention to what your exam question actually asks for. Stopping at the exact surd form versus calculating the decimal approximation can literally be the difference between full and partial marks. If the question says leave your answer in exact form, you must stop at the square root. Do not touch your calculator. But if the command word asks for 2 decimal places or 3 significant figures, you must calculate it all the way out. Always double-check the command requirement before you write down your final conclusion.
Section 5. Real-world geometry problems. Let's see how these abstract tools build the foundation for solving tangible physical problems.
Let's wrap up our case with this final challenge. We know the area of a rectangle is base times height, so x multiplied by x plus 9 equals 52. Expanding and rearranging this gives us a beautifully structured quadratic. X squared plus 9x minus 52 equals 0. If we use our factorizing skills, we find 2 mathematical solutions, x equals negative 13 or x equals 4. But remember your context. We are dealing with physical space here. Can a rectangle really have a side length of negative 13 centimeters? Absolutely not. So 4 is our only logical, undeniable conclusion. If you master these 3 rules, command word decoding, the PEL framework application, and smart time management matrix, you will conquer this exam. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.